Yes, we're recording.
Okay, so let's see, we have some homework that's due. See which one is due. So it looks like we have, on May 2nd, we have 2 sections due. Exponential functions and logs. So May 2nd is what, Tuesday? Yeah, Wednesday. Right. Okay. So let's do these today. So exponential functions and logs. Let's take a look at them. Okay, so not too big, but okay. So let's talk about exponential functions. So I think we mentioned before that this function and this function are not the same, right? They're really super different, actually, right? For example, we check different values of x, put in 0, what do you get for this one? 0. What do you get for this one? 1. Right? 2 to the 0. And put in 1, what do you get? 1. You get 1, you get 2. Put in 2, what do you get? 4 and 4. Put in 3, what do you get? 9 and 8, right? Okay, now, but when you put in, let's jump to 10. Now what do you get? 100 and 2 to the 10, right? Which is equal to 2 to the 5th squared, right? And 2 to the 5th is what?
16.
2 to the 5th equals what?
16. 32. 32.
Right, 32, right? And that's obviously bigger than 30 squared, right? So it's bigger than 900. I'll just write that. It's greater than 900. It's, so we don't have to do the calculation. Okay? And how about if we use 100? So what do I get here? 10,000, right? But what do I get here? Okay, well, let's try and make this easier. Let's say that's 2 to the 4th to the 25th, right? Does everyone agree with that? 2 to the 4th to the 25th, right? 2 to the 4th is what? 16. So that is bigger than 10 to the 25th, right? Because this is 16. That's bigger than 10, right? But 10 to the 25th is, a bigger number than you can possibly imagine, right? 10 to the 25th, right? So even when it's just 100, this is greater than 10 to the 25th. Okay, and you could do similar like when it's 1,000. Right? How big is it going to be? It's going to be ridiculously big, right? So, and the 1,000 is not a very big number to put in, right? When I do 1,000 here, what do I get? I just get 1,000,000, right? 1,000 squared is 1,000,000, right? So I just get 1,000,000. But here I'm going to get like, who knows what? I don't even know. It's going to be too, ridiculous, right? So these functions have nothing to do with each other. They look like they're the same, but they're not the same at all, right? It's like two kanji might look similar, but they have nothing to do with each other, right? The same thing with these. These two look similar, but they have absolutely nothing to do with each other. So we've studied this kind of function, but let's take a look at this one. So for example, let's graph it. Let's try and graph it. So let's graph it. So we just put in, just graph a few points. So, did we take attendance yet?
Yes.
Okay, great. Thank you. So let's graph at 0, let's graph at 1, let's graph at 2, let's graph at 3, let's graph at 4. Let's graph at -1 and -2. Okay, so let's just do that. Maybe even -3. Okay, so let's put 0. So how about 0? What do you get? 2 to the 0, we already said that's equal to, I'll put 1 here. 1. Maybe I'll put 1 here. Okay. 2 to the 0, we get 1. 2 to the 1, we get what? Right? When we put in 1, what do we get? 2. This is 2 to the x. When we put in 1, what do we get? 2. When we put in 2, what do we get? 4. When we put in 3, what do we get? 8. Okay? And how about when we put in -1? Then what do we get? 2 to the -1 is 1/2, right? 2 to the -1 is 1/2, so I'll put that here. And how about -2? 2 to the -2, what's that? Right? 1/4, so that's like here. And how about 2 to the -3? Right? So that's 1/8. So that's like here. Okay, so now we can get a picture of what this looks like. And I should have maybe... Okay, anyway. Oh, it looks something like that. Right? Everyone agree with that? Okay, now, is it ever going to touch the x-axis? In other words, can you give me a value of x for which this will be 0? No. Right? Because this is, when you put in negative values, it's going to be like 1 over 2 to the something. Let's just write like, that's not right, but so if you put in large values of x, this is going to get smaller and smaller, but it's never going to be 0. Right? So it's never going to reach the x-axis, but it's going to get closer and closer. Okay, does everyone agree with that? Okay. Okay, so we did 2 to the x. We can also look at 3 to the x. So what happens with 3 to the x? How does that behave? So let's put in 0. What do I get when I put 0 into that? I still get the same thing, 1. Okay, how about when I put 1 into that? What do I get? 3. How about when I put 2 into that? What do I get? 9. 9. Which is up here. And I can't do any more than that. And how about -1? What do I get when I put -1 in? 1/3. Which is a little, this was 1/2, so it's below that. And what do I get here? 1/9, which is, this was 1/4. Okay, so we get that one. So let's draw that. Okay, so everyone agree with this picture? Okay, how about if I did 4 to the x? What's that going to look like? This is going to be like more steep here and then decreasing more quickly here. Right? Right? And so on. Okay, so by the way, this part is called the base. This is called the exponent. Okay, so the base. So if we make the base bigger, we see what it's going to look like. Right? How about if we, what other bases can we think about? So we did 1, we did 2, we did 3. We think we know what it's going to look like for bigger bases. So what other bases could we check? Well, I guess we could try 1. What's 1 look like? 1 is kind of boring. No matter what x you put in there, you get 1. Right, so this is like a flat line at 1. So we usually don't consider 1 as a base. Okay? And what else can we check? We can check fractions, and we can check negative numbers. Right? But there's a problem with negative numbers. For example, let's try negative 2 to the x. What's the problem? What? I don't think that's right. Yeah, I don't think that's right. But anybody see a problem? How about if we take 3 to the 1/2? What does that mean? What does raising something to the 1/2 power mean? You don't remember? 3 to the 1/2 means what? No? You don't remember that? It's the square root of 3. That means the square root of 3. Right? Because remember this rule? 3 to the 1/2 times 3 to the 1/2 is equal to what? 3 to the 1, right? 3 to the 1/2 plus 1/2, right? Which is 3 to the 1. So that's 3. So that means this multiplied by it together with itself gives you 3. So that means this must be what? The square root of 3. Right? So 3 to the 1/2 is the square root of 3. So raising something to the 1/2 power means taking the square root. So with that in mind, what's wrong with this? What's wrong with this? It means if I put 1/2 in for x, what do I get? What does that mean? The square root of negative 2. Right? But we don't want to deal with square roots of negative numbers. Right? Because those are called imaginary numbers. We're not going to deal with those. So we aren't going to allow the base to be negative. Okay, so the base can be 3, it can be 4, it can be 2, it can be 10. But it's not going to be negative. We're not allowing negatives because we don't want to have to think about those. Okay, any other ones that we should consider? You might want to consider. So we checked 2, we checked 3, we thought about 4, 5, 10, and so on. We also thought about negative numbers, and we decided not to include those. What else? What else? Okay, how about fractions? What's that going to look like for the base? What about if the base is a fraction? So let's try 1/2 to the x. So let's wonder about what that looks like. What's the picture of that? Okay, so let's try and graph that one. So what's 1/2 to the 0? 1, so that goes there. What's 1/2 to the 1? 1/2. What's 1/2 to the 2? 1/4. What's 1/2 to the 3? 1/8. Okay, so we're getting that picture. What's 1/2 to the negative 1? That's 1 over 1/2, right? Which is 2. So it's 2. So we're getting this picture, right? Okay, what's 1/2 to the negative 2?
4.
4. So we're getting this picture. Okay. So we see that for 1/2, it doesn't look like the other ones. It looks like that. And if it's 1/3, it's gonna look similar. Okay? 1/3. This is going to be. This was 1/4. Now it's going to be 1/9. This was 1/2. Now it's going to be 1/3. So it's going to be lower. So 1/3 is going to be like this. Okay? Does everyone get it? So these are different examples of exponential functions. Okay? And so we need to know what they look like. Okay? You need to know what they look like. So these come up in finance. This exponential functions come up in finance. When you're talking about interest. Okay? So we need to know about them in this course. All right? Anybody have any question about that? Okay, so let's look at the homework for these. Okay, so this is 2 times an exponential function. Okay, this is also, I think they also call this an exponential function. So any number times an exponential function is an exponential function also. I think they're also called exponential function. Okay? Okay, everyone understand? And they say, graph the given function using a chart of values, and then they're just saying, look at x between -3 and 3. Okay? And the question is, which is the proper graph? So before we do that, what would happen if I took the first one that we did, 2 to the x, and I multiplied that by 3? How's that going to change the picture? So when we got this point, what was that point? That was when x was 1, we got 2, right? Now we're going to get what? This is going to be 2, so it's going to be 3 times 2, which is 6. So it's going to be just higher, right? So it's just going to be the same thing, but higher. And the other one's going to be the same thing. I think this was wrong, sorry, this one. So it's going to be the same thing, but higher, and it's going to be down here. I guess it's going to be also higher. Okay, but the same shape. Right? Okay, so the question is, which graph should we choose here? So which ones can we rule out? I don't think we saw anything like this, right? So this is probably not right. And I don't think we saw anything like this. So this is probably not right. So we can basically rule those out, right? Everyone agree with that? And then, so we have these two to choose from. So this one is going to be what? When the base is a fraction, right? So we don't have a fraction here. The base is 3. So it must be this one. Okay? Okay. You can watch this one. Okay, here's another one. Supply a technology formula for this. So they're not asking you to do anything with this, just asking you how to write this, how to rewrite it, that's all. So the point here is, in rewriting it is, if you have to type this in Microsoft Word, you have to use a superscript to type this, right? Right? Which is a kind of a pain in the neck. You probably haven't done it very much, but I have, and it's not fun. You have to keep switching, and It's really, so this is just an alternative to doing that. So instead of writing e to the x, you can write exp x. Okay, it's just another way of writing e to the x. Okay, but I don't have to use any subscripts to do that. Okay, does everyone understand? That's all they want. That's the only purpose for this. So which one of these expresses this? So this says e to the 1, right? This says, what? E to the 1 plus x. Okay? Everyone understand this, the way this works? It's easy, it just makes it easier to type. Okay, so which is the correct one? 1, 2, 3, or 4? 3, right? Does everyone agree? It's 3. This one. This is e to the 1 plus x over x, which is what we wanted, e to the 1 plus x over x. Okay? So that's that one. Okay, next one. Find the equation of an exponential function that passes through the pair of points given below. So we want an exponential function that goes through this and this. And by exponential function they mean, let's see, how can I draw? What's in Microsoft 10? Let's try this, the old Paint. Okay, so they're asking for a function like this. Y equals